There are many theories about the origins of Jupiter. Here's what we think happened. Nearly 5 billion years ago, a star in our galaxy exploded. The explosion caused a nearby cloud of gas and dust to collapse and flatten into a spinning disk. Most of the gas and dust collected into a hot, dense core that became our Sun. The remaining debris formed the planets and other small bodies in our solar system. And the majority of that debris came together to form the giant planet, Jupiter. Of all the 8 planets, we believe Jupiter formed first. Understanding the formation of Jupiter is essential to understanding the origins of our entire solar system, the formation of Earth, and the most basic foundations of life as we know it. Jupiter is 1,300 times the volume of Earth, more than twice the mass of all the other planets combined, the 5th planet from the Sun, and the largest planet in our solar system. Because of its enormous size and powerful gravity, it is believed that Jupiter has influenced the formation and evolution of the other bodies that orbit our Sun. Unlike Earth and the other smaller planets, the composition of Jupiter has remained unchanged since the solar system began. Like a time capsule, Jupiter can help us reconstruct nearly 5 billion years of history. Mission Juno will help prove or disprove theories about the types and amounts of materials that contribute to the composition of Jupiter. By peering beneath its clouds and discovering what Jupiter is truly like, Juno will also test our ideas about the formation of planets, as well as other major secrets of our solar system. Measuring the amount of water in Jupiter will help us understand how and where in our solar system the giant planet formed. Mapping the gravity and magnetic fields of Jupiter teaches us about the planet's hidden interior and whether it has a solid core. In our quest to unlock the history of the planets, Jupiter is the gateway, and Juno holds the key. Hundreds of scientists and engineers in 5 countries have been working for more than 10 years to design and build the Juno spacecraft. This solar-powered probe will travel 400 million miles into space with instruments uniquely built to withstand deadly radiation and the fiercely cold environment of Jupiter. Juno will conduct an unprecedented examination of the atmosphere, the interior, and the vast magnetic field of the giant planet. On August 5, 2011, one of the world's most powerful rockets is set to take off. The Atlas V 551 rocket, weighing 650 tons, launches and reaches a top speed of 4,500 miles per hour. The rocket hurtles through Earth's atmosphere, exhausting its fuel and reaching orbit in just over 10 minutes. The payload fairing falls away, revealing the Juno spacecraft within. Once in its proper orbit, the Centaur booster gives the probe its spin and sets Juno free on its journey to Jupiter. In the shadow of our planet, the spinning Juno spacecraft deploys its 3 massive solar arrays, which will power the mission for the next 6 years. After these arrays lock into place, power from the sun streams into the circuits of Juno for the first time. Escaping the gravitational pull of Earth, Juno is still held to its trajectory by the sun's gravity. The Juno spacecraft is carried 50 million miles into space, as far as the orbit of Mars. A burn from the main engine directs Juno back toward Earth for a final encounter with its home planet. Using Earth's gravity for energy, Juno slingshots into space, increasing its speed and receiving the boost it needs to pull away from the sun and coast all the way to Jupiter. After 5 years of being alone in space, Juno approaches Jupiter and begins reaching a top speed of 160,000 miles per hour, officially becoming the fastest man-made object in history. The main engine ignites to slow down the spacecraft, and Juno is captured by the powerful gravitational pull of Jupiter. Settling into the most challenging orbit ever attempted, Juno will come as close as 3,100 miles to the planet's cloud tops. Juno will continually duck below deadly radiation belts as it studies Jupiter in unprecedented detail for more than a year. Juno will use remote sensing to inspect Jupiter from its innermost core to the outer reaches of the magnetic bubble the giant planet inhabits. Juno will be the first probe to visit the regions above the poles of Jupiter, witnessing energies in the magnetosphere that create its extraordinary ultraviolet auroras. After orbiting Jupiter for over a year, the Juno craft will dive deep into the atmosphere and burn up. But the mission will never truly end. No matter how many answers we find, there will always be more questions. Our search for understanding and meaning continues.